In this lesson, we're going to go over several topics that might appear on the SAT and some practice questions. So let's start with solving radical equations. Notice how it says at the top to always check for extraneous solutions, and we'll go over what that means in a few minutes. So let's start with number 1. We have 3x, the square root of 3x plus 1 is equal to 4. If we want to solve this for x, our first step is we need to get rid of this radical here. And the way that we do that is we just need to square both sides. So just like you can undo multiplication with division and you can undo addition with subtraction, you can undo a square root by squaring both sides. So then the left side is going to become 3x plus 1, and the right side becomes 4 squared or 16. And then we can just solve for x, so 3x equals 15, x equals 5. And it's always important to check your solutions for radical equations. So if we plug this in, we get the square root of 16 is equal to 4, which is correct, so that we know the solution is correct. Let's look at the second problem. So over here, before we square both sides to eliminate this radical, we should isolate the radical first. So we should get rid of any numbers surrounding it. So to get rid of numbers surrounding it, we're going to get rid of this 3, right? So if I subtract 3 from both sides, I get the square root of 7 minus x is equal to 2. And now I can square both sides, and I get 7 minus x equals 4. So x equals 3. And then I can go back to my original equation and plug this in. I get this becomes the square root of 4, which is 2, and then plus 3 is equal to 5, so then that works, and I know my solution is correct. Alright, now we have the cube root of x plus 15 is equal to 3. So just like to undo a square root, we squared both sides. To undo a cube root, we're going to cube both sides or take both sides to the power of 3. So on the left side, we're going to be left with just x plus 15. And on the right side, we're going to be left with 3 cubed, or 3 times 3 times 3, which is 27. Now we can subtract both sides by 15, and we get x is equal to 12. And again, we can plug this into this equation, right? And we get cube root of x plus 15, or cube root of 12 plus 15 if x is equal to 12. So cube root of 27 equals 3, which is correct. Alright, now we have 2 times square root of x is equal to x. So the way that we're going to solve this is I'm going to first isolate my radical again. So I need to get rid of this 2. And I'm going to do that by dividing both sides by 2. So I end up with root x equals 1/2 x. Now I'm going to square both sides, and I end up with x equals 1/4 x squared. So when we square 1/2 x, when we square that term, this exponent is going to apply to both the 1/2 and the x. So we end up with 1/4 x x squared. Now what we're going to do is move everything to one side. Notice how this is a quadratic equation, right? We have an x squared term, we have an x term. So we're going to move everything to one side. I'm going to move this x to the right side, and I get 1/4 x squared minus x equals 0. That's what I get if I subtract both sides over here by x. Now I'm going to factor out an x from both terms. So I get 1/4, x times 1/4 x minus 1 equals 0. Now I can solve for my two solutions. One of them is when x equals 0, and the other one is when this factor equals 0, right? So when does 1/4 x minus 1 equal 0? That's when x is equal to 4. So if x equals 4, this factor becomes 0, which makes the entire thing become 0. And if x equals 0, then this factor becomes 0, which makes the entire left side become 0. So my two solutions are x equals 0 and x is equal to 1/4. X equals 0 and x equals 4. And I can go back and plug them into this. So if I plug in, let's say x equals 0, then I get 2 times root 0 equals 0, which is true, because the square root of 0 is just 0. And if I plug in x equals 4, then I get 2 times root 4 equals 4, which is true because 2 times root 4 Root 4 is just 2, so this is 2 times 2, right? Which we know is 4. So both of these solutions work. Okay. Now we're going to take a look at number 5. In this case, we have 2 radicals, so I'm going to square both of them. If I square both sides, that's going to eliminate the radical on both sides, and I end up with 3x plus 4 equals 4x plus 3. I can move all of my x's to one side and all my constant terms to the other side, so I'm going to subtract both sides by 3x, and I get 4 equals x plus 3, and then subtract both sides by 3, and I get x equals 1. Now I can plug that back into my original equation. So my original equation is root 3x plus 4 equals root 4x plus 3. If I plug in x equals 1, I get the square root of 7 equals the square root of 7, which is true, so that solution works. Okay, now let's talk about what extraneous solutions are. So notice how over here on number 6, this is a positive square root, right? What I'm gonna do is set up the same equation, except I'm going to make this square root negative. So instead of 2x minus 1 equals root 8 minus x, I'm gonna have 2x minus 1 equals negative root 8 minus x. And now I'm going to solve both of these. So for this first one, I'm going to solve this by squaring both sides, and I end up with 2x minus 1 squared equals 8 minus x, right? So squaring it eliminates the radical. Over here, I'm going to solve it in the same way. So square both sides, and I end up with 2x minus 1 squared is equal to 8 minus x. The reason why it becomes 8 minus x is when you multiply a negative times a negative, that's going to cancel out the negative sign, right? So if we do negative root 8 minus x times negative root 8 minus x, not only is this going to cancel out the radical on both of them, it's also going to cancel out the negative sign, because negative times negative equals positive. Now we have an issue because we started off with 2 different equations, and now after the first step, when we square both sides, we end up with the same equation, right? And when we solve these 2 equations, we're actually going to end up with the same solution, right? So if I solve this one, I'm going to end up with 4x squared minus 4x plus 1 on the left side equals 8 minus x. And then if I move all of my terms to the left side, I get 4x squared minus 3x minus 7 equals 0. And if I solve this using the quadratic formula, I'm going to end up with x equals 14 over 8 and x equals negative 1. And since these 2 equations here are the same thing, obviously if I solve this one, I'm going to end up with the same solutions. X equals 14 over 8, x equals 1. Or x equals 14 over 8 and x equals negative 1. So let's go over it one more time. We started off with 2 different equations. Left one is 2x minus 1 is equal to the positive square root of 8 minus x, and the right one is 2x minus 1 is equal to the negative of root 8 minus x. But after we square both sides, they become the same equation, which means that we get the same solutions, 14 over 8 and negative 1. So this is where extraneous solutions come from. If we take a look at these 2 solutions, x equals 14 over 8 and x equals negative 1, why don't we go ahead and plug them into our original equation? So we have 2x minus 1 equals root 8 minus x. And if we're testing these 2 solutions, let's go ahead and plug them in for x. So the first one was 14 over 8, so 2 times 14 over 8 minus 1 equals the square root of 8 minus 14 over 8. 28 over 8 minus 8 over 8. 1 is just 8 over 8, right? And then that's equal to 64 over 8 minus 14 over 8. So 20 over 8 equals the square root of, let's see, 50 over 8 let's see, was there a mistake here? Oh, there's a mistake. Sorry about that. Anyway, so 20 over 8 equals the square root of 25 over 4. If we were to simplify 50 over 8, it becomes 25 over 4. And then we get 20 over 8 is equal to square root of 25 over 4 is the same thing as square root of 25 over square root 4. So we get 20 over 8 equals 5 over 2, which is true, right? Because if you reduce 20 over 8, it's going to become 5 over 2. So our first solution, which was x equals 14 over 8, works. Okay, now let's try the second solution, which was x equals negative 1. So I'm going to plug in x equals negative 1, and I get 2 times negative 1 minus 1 is equal to the square root of 8 minus negative 1. So now I end up with, on the left side, negative 2 minus 1 equals the square root of 9, or negative 3 equals 3, which we know is not correct, right? So notice how our second solution, which was x equals negative 1, doesn't work for the positive radical. But if we were to plug it in when we had a negative radical, that solution would work, right? So x equals negative 1 would work if our radical was negative. Let's test it out. So we have 2x minus 1 equals, in this case, a negative root 8 minus x. I plug in negative 1, I get negative 3 equals negative root 9, or negative 3 equals negative 3. So that solution works for the negative radical, but not the positive radical. So this solution is extraneous because it wasn't meant for this equation. It was actually meant for this equation. But since on the second step, both of these equations became the same and their solutions became the same, the solutions sort of get jumbled, right? So that's called an extraneous solution. So over here, we tested x equals 14 over 8 and x equals negative 1 on our original equation, and we found that only x equals 14 over 8 works. X equals negative 1 does not work, so that's an extraneous solution, and we don't count it. So then our only solution is x equals 14 over 8. Okay, now let's try this one. So we're going to isolate the radical, so we're going to subtract both sides by 3, and we get root 5x plus 6 equals 9. Square both sides, and I get 5x plus 6 equals 81. And if I subtract 6 from both sides, 5x equals 75, and divide both sides by 5, x equals 25. And then if I plug this in, I get 3 plus root 81 equals 12, which is true because 3 plus 9 does equal 12. So that solution works. Alright, now let's try this one. Actually, we'll skip this one. Why don't we go to the, number 9 instead? So in this case, again, we have two radicals. So what we're going to do here is I'm actually going to move this one to the left side. So I'm going to subtract both sides by root 2x minus 1. And I end up with root 3x minus 7 equals negative root 2x minus 1, because I subtracted both sides by root 2x minus 1. Now I'm going to square both sides like I did before, which is going to get rid of the radical, and it's also going to get rid of this negative sign, right? So I get 3x minus 7 equals 2x minus 1. And then I'm going to move all my x's to the left side and all my other terms to the right side. And I end up with x is equal to 6 as my only solution. Now if I go ahead and plug that into this equation, I get square root of, let's see, 18 minus 7 is 11. And then plus square root of 11 equals 0, which we know is not true, right? So the solution doesn't work. It's extraneous, and since that was the only solution we had, then there's no solution to this equation. So always make sure to check and double check your answers for radical equations. Okay, now let's take a look at an example problem for this from an SAT practice test. So this one says, what is the smallest solution to the given equation? So we have the square root of x minus 2 squared is equal to square root of 3x plus 34. So, like always, we're going to start off by squaring both sides to get rid of the radicals, and we end up with x minus 2 squared equals 3x plus 34. Now I'm going to expand the left side, so I get x squared minus 4x minus 4, plus 4, and you can do that by doing this, x minus 2 times x minus 2, and if you multiply it out, you'll get this, and then that's equal to 3x plus 34. Now what we can do is move all of my terms to the left side, so I get x squared minus 7x minus 30 equals 0, and I can go ahead and factor this, two numbers that add up to negative 7 and multiply to negative 30. Let's see. That's going to be negative 10 and positive 3, so I get x minus 10, x plus 3, and so my two solutions are x equals 10 and x equals negative 3, and it's important to go ahead and plug these back in to check. So if I plug in x equals 10, then I get the square root of 8 squared, or square root of 64, is equal to square root of 64, so that works. And if I plug in x equals negative 3, let's see what I get. I get the square root of 25 is equal to the square root of 25. So this one should work as well. So since both of those solutions work, the smallest of them is going to be x equals negative 3, so then that's my answer. And I can also solve this equation by just plugging this into decimals. If I plug in both the left and the right side of the equation into decimals and see where they intersect, that's going to give me my solutions as well. So we can go ahead and try that. So the first one was the square root of x minus 2 squared, and the second one was the square root of 3x plus 34. So we can see that they intersect at 2 points, x equals negative 3 and x equals 10. So those are my two solutions, and the smallest of them is negative 3. Alright, now let's talk about solving absolute value equations. So when you're solving absolute value equations, first let's talk about what absolute value is. Let's say I add a number line, and I have 0 here, and let's say this is 5 and this is negative 5. So over here, if I go over here, the value of this number is 5 and the value of this number is negative 5. But if I were to ask you what the distance is between 0 and 5 and 0 and negative 5, the distance is 5 in both cases, right? If we're talking about just the distance. So that's what absolute value is. It's just the distance from a number to 0 on the number line. So when you're dealing with absolute value, that means that negative signs don't matter. So the absolute value of 5 is 5 because that's the distance between 0 and 5, and the absolute value of negative 5 and is also equal to 5 because the distance between 0 and negative 5 is still 5. So that means that when you're solving absolute value equations, once you isolate your absolute value, you're going to end up solving two separate equations. So here's what that means. Let's say we have absolute value of negative 4 plus 5x equals 16. So what we're going to do here is we're going to set negative 4 plus 5x equal to positive 16, and we're also going to do negative 4 plus 5x equals negative 16. So the reason why we're doing that is because let's say that we don't know what this distance is. Let's say that this distance is x. Notice how the distance from 0, or the distance x could be the distance from 0 to 5 or from 0 to -5, right? So if you wanted to solve this, then you would say that x equals the absolute value of +5 and also the absolute value of -5, right? So that's why we're going to set our absolute value equations to two separate or two opposite signs. All right, so we have -4 plus 5x equals +16 and -4 plus 5x equals -16. So let's start with the left one. All we need to do is solve this. So we get 5x equals 20, x equals 4. And over here, we can also solve this. We get 5x equals -12, x equals -12 over 5. And just like with radical equations, it's always important to check your answers for absolute value equations. So if you plug in x equals 4 and x equals -12 over 5, both of them work in this original equation, so we can use both answers. And we can go ahead and just quickly plug in x equals 4 to check. So if we plug in x equals 4, we get the absolute value of, let's see, -4 plus 20, which is equal to 16. -4 plus 20 is 16, so the absolute value of 16 equals 16, which is true. Alright, now let's look at number 2. So before we actually solve this, what we need to do is isolate the absolute value expression. So first, let's get rid of this 3. So I'm going to subtract 3 from both sides, and I end up with negative times the absolute value of 8x minus 6 is equal to 0. And now I'm going to divide both sides by -1, so I can get rid of this negative sign. And I get absolute value of 8x minus 6 is equal to 0 still. And now, obviously, there's no positive or negative 0. So there's no need to set this equal to two separate equations. We just do 8x minus 6 equals 0 and just solve it like that, right? So x is going to be equal to 6 over 8. And we can go ahead and plug this in. So 3 minus absolute value of 8 times 6 over 8, which is 6 minus 6 equals 3. So basically 3 minus 0 is 3, which is true. So we know that that solution works. Alright, now let's try this one. We have 6 plus 5 times the absolute value of 2x minus 5 is equal to -8. So we're going to subtract both sides, but again, first we're going to isolate this absolute value expression. So we're going to subtract both sides by 6, and we get 5 times absolute value of 2x minus 5 equals -14. And now we're going to divide both sides by 5, and I get absolute value of 2x minus 5 equals -14 over 5. And absolute value always needs to be positive, right? Because the distance between any two values, even if it's, the distance between 0 and any number is always going to be positive, right? Even if that number is negative. So that means that if you isolate an absolute value expression and you find that it's equal to a negative number, there's no way to solve this, because whatever is in here is always going to be positive no matter what. So there's no way it can equal a negative number, which means that there's no solution for this equation. Let's take a look at an example problem now from a practice SAT. So we have 2 times the absolute value of 4 minus x plus 3 times the absolute value of 4 minus x equals 25. So what we're going to do here is, just like if you add 2x plus 3x, you can turn that into 5x, right? Notice how both of these absolute value expressions are the same, right? 4 minus x and 4 minus x. So we can actually combine these two terms into 5 times the absolute value of 4 minus x. So over here, 2 times the absolute value of 4 minus x is like saying that I have 4 minus x plus 4 minus x, right? And over here, 3 times the absolute value of 4 minus x is like saying I have this 3 times, right? So if I add them all together, I'm going to have 5 times the absolute value of 4 minus x. And then that's equal to 25. And now I can isolate my absolute value expression by dividing both sides by 5. And I get absolute value of 4 minus x equals 20. Now I can set this equal to positive and negative 20. So I get 4 minus x equals positive 20 and 4 minus x equals negative 20. So I can solve both of these over here. X is going to be equal to negative 16. Over here, x is going to be equal to let's see, if you add x to both sides and add 20 to both sides, you're going to end up with x equals 24. So then those are my two solutions, and they're asking for the positive solution here. So then the positive solution is x equals 24. And again, you can also solve this using Desmos. If I plug in the left side of the equation was 2 times the absolute value of 4 minus x plus 3 times the absolute value of 4 minus x. That's the left side of the equation. The right side of the equation was just 25. Or I can do y equals 25. And notice how they intersect at 2 points. X equals negative 1 and x equals 9. So then those are my two solutions. Let's see, did I do that correctly? Oh, this should be... Yeah, that's correct. Let's go back and let's actually check our solutions and make sure that they work. So if I plug in x equals negative 16, then I end up with 2 times the absolute value of 4 minus negative 16, which is 20, and then plus 3 times the absolute value of 20 equals 25. So we might have made a miscalculation somewhere here. Oh, it's right here. If we go back to when we were solving this, right? Over here, we had 5 times the absolute value of 4 minus x is equal to 25. When you divide both sides by 5, it should be 5 on the right side, right? So let's redo this here, right? We have 5 times the absolute value of 4 minus x is equal to 25. I'm going to divide both sides by 5, and this should be 5, not 20. So that's the importance of always checking your work. Now we can set this equal to 4 minus x equals 5, and 4 minus x equals negative 5. And if I solve these two, I'll get x equals negative 1 and x equals 9. So those are my two solutions, and if I plug them in, then they will both work. So yeah, you can solve this either algebraically or you can plug it into the graphing calculator and see where they intersect. Okay, now let's talk about exponent properties. So let's start with this one. Let's say we have x to the power of 6 times x to the power of 3. This is going to be equal to x to the power of 9. So what this property is if you have two exponents with the same base and they're multiplying each other, you just add their powers. So x to the power of 6 times x to the power of 3 becomes x to the power of 6 plus 3, or x to the power of 9. So this property, if you write it down, you have x to the power of m times x to the power of n is equal to x to the power of m plus n. Alright, now let's look at the next one. If you have x to the power of negative 3, so all that means is you're going to have 1 over x to the power of 3. So whenever you have a negative exponent, what that means is that you take the reciprocal of it. So the reciprocal of x to the power of 3 is 1 over x to the power of 3. So that's what we're going to do there. Over here, we have y to the power of 3 to the power of negative 2. All we need to do here is multiply our two exponents. So we end up with y to the power of negative 6, right? 3 times negative 2. And if you take y to the power of negative 6, another way of writing that is 1 over y to the power of 6, right? So we can take the reciprocal since that's a negative exponent. Now we have y to the power of 6 over y to the power of 9. All we need to do here is subtract the exponents. So whenever you have the same base and you're dividing it you can just subtract their exponents. So then this becomes y to the power of 6 minus 9, or y to the power of negative 3, which is 1 over y to the power of 3. Alright, now if you have x to the power of 2 times y to the power of negative 3, all to the power of negative 5, what we're going to do here is just apply this exponent to both the x and the y separately, so it becomes x to the power of negative 10, y to the power of 15. So if we multiply 2 times negative 5, then it becomes negative 10, and then negative 3 times negative 5 is 15, so we have x to the power of negative 10, y to the power of 15. Another way we can write this is 1 over x to the power of 10, since x has a negative exponent, and then times y to the power of 15, which is y to the power of 15 over x to the power of 10. Alright, 8 to the power of 2 over 3, so how you can rewrite this is the cube root of 8 squared. So whenever you have a fractional exponent, the numerator becomes your new exponent, and the denominator becomes the root that you take. So we're taking the third root of 8 to the power of 2. And then 5 to the power of 0, any number to the power of 0 is just going to be 1. 2/3 to the power of 4, so all you need to do here is apply the exponent to the numerator and denominator separately. So we have 2 to the power of 4 over 3 to the power of 4, which is going to be 16 over 81. Alright, so those are some properties of exponents. Now let's practice them. So let's say we have a problem like this. What we're going to do here is first apply this 3 exponent to these numbers in here. So this part is going to stay the same. And then over here, if I apply 3 to negative 2, right? So I get negative 2 to the power of 3, that's negative 8. Negative 2 times negative 2 times negative 2 is negative 8. And then if I apply the 3 exponent to this, it's going to multiply with this. So we get x to the power of negative 6. Now I can multiply these two numbers. So negative 4 times negative 8 is 32. And then x to the power of 2 times x to the power of negative 6. Again, I'm going to add their exponents. So it becomes x to the power of negative 2 plus 6, or x to the power of negative 4. Alright, now let's take a look at this one. So all we need to do in this one is apply the negative 3 to all 3 numbers. So 2 to the power of negative 3 is, let's just write it like this, 2 to the power of negative 3 for now. And then x to the power of negative 5 times negative 3 is x to the power of 15. And y to the power of 4 times negative 3 is y to the power of negative 12. So 2 to the power of negative 3 is like saying 1 over 2 to the power of 3, or 1 over 8, times x to the 15th, times 1 over y to the 12. And this reduces to x to the 15th over 8y to the 12th. Okay, now let's take a look at an example from an SAT practice test. It says, which expression is equivalent to m to the 4th, q to the 4th, z to the negative 1 times m q to the 5th, z to the power of 3. So what we need to do here is just multiply each one, right? So m to the 4th times m is going to be m to the 5th. If you add their exponents, this is like m to the 1st, right? And then q to the 4th times q to the 5th, if you add their exponents, becomes q to the 9th. And z to the negative 1 times z to the 3rd is going to be z to the 2nd. So then that's going to be B. Alright, now let's take a look at another problem dealing with exponents. So we have the function f is defined by the given equation. If g of x equals f of x plus 2, which of the following equations defines the function g? So this is f of x, 9 times 4 to the power of x. So we know that g of x is equal to f of x plus 2. So wherever we see an x, we're just going to replace that with x plus 2. So I get 9 times 4 to the power of x plus 2. The problem is that this isn't actually one of our answer choices, right? So what we can do here is, remember how x to the power of 1 times x to the power of 2 becomes x to the power of 3, right? So whenever you have the same base, you just add their exponents, right? Well, that also works in reverse. If I have x to the power of, let's say, y plus z, this is equal to x to the power of y times x to the power of z. So I just did it in reverse, right? So if I have 4 to the power of x plus 2, this is actually going to be equal to 4 to the power of x times 4 to the power of 2, because it works backwards. So if I had 4 to the power of x times 4 to the power of 2, I just add their exponents, but I can also do it in reverse. So what I can do is replace this with 4 to the power of x times 4 to the power of 2, and then this becomes 9 times 4 to the power of x times 4 to the power of 2. And while I can't multiply 9 by 4 to the power of x, I can multiply it by 4 to the power of 2, because 4 to the power of 2 is just 16, which is just a number, right? So I get 9 times 16 times 4 to the power of x, and now 9 times 16 is going to be, let's see, 90 plus 54, which is 144 times 4 to the power of x. And that is one of the answer choices. So you can also use these properties in reverse. Alright. That's where we're going to leave off for this lesson.